started. Quiet, 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 much quieter. Okay. I think we answered B. Is that correct?
Yes, we're currently on C.
Okay. So I want to estimate the error in evaluating natural log of 3/2 by using the first 5 non-zero terms. Well, first I have to go remind myself what the function was. Yes, and it was ln of 1 plus x. So if the function is ln of 1 plus x, what am I actually plugging in if I'm plugging in natural log of 3/2? What is x? A half. Does everyone agree with that? So I am plugging in a half. So I want to know if I'm plugging in a half, what is my error going to be? Well, first of all, I need the first 5 non-zero terms. Have we written those out yet? Okay, so
Why is it?
because the function was 1 plus x, and so 3/2 is 1 plus a half. Does that make sense? So that makes it kind of a weird question, because it's not plugging in a half or 3/2. It's plugging in a half. We did the first 3. Is that what you said? So we need to go all the way out to 5.
Teachers, would you please check your email and send the students that I have an email to me sometime this hour, please? Thank you.
I checked. Y'all weren't. Okay. Remember, the error in an alternating series, timeout, is this an alternating series? It is, in fact, an alternating series. The error is less than the absolute value of negative x to the 6 over 6. Where in the world did I get that? The next term, right? It is the next non-zero term. Okay, and I want to evaluate this at the distance from my x value to the center. So I need to go back. Oops. Come on, computer. Remember this series converged when x was between -1 and 1? What is the radius of that interval? Good. 1. And so I went, yeah, sorry. I don't need to know that. Sorry, I don't need to know that. Okay, I'm going to plug in a half for my x, because I want to evaluate the error when x is a half. I didn't need to know that. Okay, and type that in the calculator. Do that for me.
It's 0.0. It's a negative.
It is absolute value, right? So it's the error is less than the absolute value of, what'd you get?
Negative 0.002604.
Okay. So you could leave it as a decimal or as a fraction, either way. I did what? What did I do? It was a fraction. It doesn't matter. Decimals are fine. On the AP exam, mental note, if this truly is a non-calculator question on the AP exam, don't do this. Leave it like that. If it's a calculator, go ahead and plug it in, but if not, don't, because you might mess up.
So how will any of the
It would be like this. Like, you'd just leave it. I would definitely recommend leaving it. Any questions so far? Use the result in part A to determine the logarithmic function whose Taylor series is this. What are your thoughts?
That's 2x. Well, we know the base. We know the base function.
Use the result from part A to determine the logarithmic function whose Taylor series would be that.
So it's going to be 2.
What would be a good idea to start this problem? Break it up. What do you mean break it up? Okay. My recommendation would be to look and see what this looks like. Do you know what I mean by that? Write out a few terms. How would you write out a few terms?
So like you plug in.
Plug in the 1 for n. This is not a requirement. You wouldn't have to. But to me, I think it would be helpful for us to look at what the sequence looks like. So, if I plug n being 1, is that, it doesn't matter. It's positive 1 x squared over 2 minus x to the 4th over 4 plus, everyone agree with that next? Good so far. X to the what? Any questions so far? Okay, I want to sit here for a minute and I'm going to pause and I want you to think. See if there's anything you could come up with where the logarithmic function would equal that. All right, remember the natural log of 1 plus x was x minus x squared over 2 plus x cubed over 3. Everyone agree? What's one thing you notice immediately that I'm going to have to do to make this happen? Okay, all the powers need to be even, right? So I'm thinking I need an x squared instead of an x. Everyone agree with that? That's the only way. To me, this is a very hard AP problem. They're not all this hard. You saw A, B, and C, much more doable. This one was much worse. So that would make x squared minus x to the 4th over 2 plus x to the 6th over 3. Are we there yet?
So we do 1 plus x squared over 2. But everything is everything over 2.
Everyone agree? That is the logarithmic function. I think the AP rubric, it's been a while since I've looked at it, but I think the AP rubric writes it this way. But of course, if you wrote it divide by 2, that would be the same thing. To me, that was a very hard question because you had to think about, I don't know, how'd y'all feel about it? Not hard? Hard, very hard, okay. I think it was tough. So far. It does appear to like one, except the factorials. Now, they gave us a hint, because if you had just had to do this from scratch, that'd be even harder. They did tell us what logarithmic function, so that helped a little. We knew we needed to somehow manipulate 1 plus natural log 1 plus x. For this problem, definitely not, because it said determine a logarithmic function. I would say no, because it'd be really hard to get rid of the factorial. But I could always be proven wrong as well. So I'm going to skip this one for just a minute to make sure that we have time to get the Lagrange error bound in, but we will go back to that one. Lagrange error bound. So we have two options with error. Two options with error. Either the series alternates or it doesn't. One of two. So either the series alternates or it doesn't. If it alternates, we will always use the alternating series error bound for error. If it doesn't alternate, then we will use the Lagrange error bound. So when the Taylor series doesn't alternate, we can still find the error using the Lagrange or Lagrange, may be a better pronunciation. The error is still tied to the next unused term according to this formula. The fn+1 of z is the maximum value the derivative can take on in the interval. So we'll have to talk about that, about how to find that. We are going to be looking for a safe bound. It doesn't have to be the lowest bound on that derivative. X is the value of the polynomial function centered at A. And we will do an example, of course. Let me think about that. I don't know. I do not know that answer. I know you wouldn't want to use it because the alternating series will be easier because you don't have to think about the maximum derivative value. But I want to answer your question correctly, so let me look and see if I can find your... Because I don't know that it's a no. It's a wouldn't want to, but we can find out. I think the answer is yes, you could use the Lagrange error bound, even if it alternates.
So if we just have to get
Yeah. Now you may not, the AP problem may not give you enough information to use the Lagrange error bound, but yes. Do you know what I mean by that? Because you have to have more information in the Lagrange than you do in the alternating series. Because alternating series, you only need the next term, which is quite easy to find. But reading the Lagrange, page 502 has the Lagrange error-bound formula, and I don't see anything that says that you can't have an alternating series. So. This is a calculator allowed problem. Those are fewer and farther between as you get into the newer AP problems on Taylor. Part of that's probably because of your TI-89. Have y'all seen the Taylor button on your TI-89? It's under F3. If you put in a function, it will write the Taylor polynomial expansion for you. So because of that, most of these show up on non-calculator. However, or on, yeah, non-calculator. However, you can see how this one could show up on a calculator even now because of the way it's where it doesn't give you a function. So this is 1999 BC number 4. The function f has derivatives of all orders for all real numbers x. Assume that f of 2 is -3, f prime of 2 is 5, f double prime of 2 is 3, and f triple prime of 2 is -8. Write the third degree Taylor polynomial for f about x equal 2 and use it to approximate f of 1.5. It is. I hope. Yes, it is. Are we getting good at the Taylor polynomial, just writing it out?
Yeah.
Oops, I don't need anything there. -3 plus 5 times what? Plus 3 over and minus or plus negative. It makes no difference how you do that. That would be points on the AP exam, just knowing that. It says the fourth derivative of f satisfies the inequality. Oh, thank you. I'm glad y'all are paying attention. It is a calculator problem. What am I going to do? Plug it in. Which, while we're doing this, let me go ahead and show you what your calculator does, because it's just too cool not to. By the way, is anyone in here missing a TI-84? No. If you are, I have one. This can't be used on this problem, but Taylor, if you click the Taylor button, say you want the Taylor expansion of cosine of x, comma x, and if you want the, what is it, third degree or 3 terms? I think so too. So comma 3 would give you the, whoops, yeah, would give you the, nope. Yeah, it does give you the degree because cosine is, yeah. So it gives you the Taylor polynomial, which is pretty cool. Again, probably won't be able to use that on the AP exam, but hey, if you can, use it. Now what I did want to show you was if you want to, you could type all this in and put 1.5 in, although it's probably easier just to type it. Just do it, I don't know. If this were non-calculator, Don't multiply it out. Negative 1/2.
So all you can do is negative 4.
Just write it down. Now, since it's calculator, I have a feeling you're going to need that answer. You might not, though. You probably don't. Negative 1/2 squared over 2 factorial minus 8 times negative 1/2 cubed over 3 factorial. Has someone started typing that yet?
Yes. It is negative 4.9.
Negative 4.958. All right, part B. I am taking Nicholas's word.
Well, I so he said like negative 49.58.
Okay, the fourth derivative of f satisfies this inequality. It's always less than or equal to 3 for all x in the closed interval 1.5 to 2. Use the Lagrange error bound on the approximation of f of 1.5 to explain why f of 1.5 does not equal negative 5. Well, how could an error even help me explain this? Yeah, if it's only so far off, then it can't get all the way to negative 5. So I really need to find out how far off it could be. And I know that the error is less than f of the next derivative, n plus 1. Well, we did the third derivative, correct? So the fourth derivative, and remember, it said that f of n plus 1 of z. It's not the derivative at a certain z. We don't really care what z is. It is the maximum value the derivative takes on the interval. Well, luckily, what do they tell us? The maximum value the fourth derivative takes on is 3. The derivative is always less than or equal to 3. Does everyone see that? So they tell us that because we need that information for the Lagrange error bound. Times 1.5 minus 2 to the 4th power over 4 factorial. Does this still look like the next term, sort of? The only difference is this is a maximum value of the derivative on the interval. That value is 0.00. Okay. And so then I would show that negative 4.958 plus or minus, we really are talking minus here, 0.007813 is still a bigger number than negative 5. Everyone agree with that? Therefore, f of 1.5 cannot equal negative 5 because the error on this Taylor approximation is less than 0.008. Is that a pretty good approximation to be less than 0.008 on your error? And how could you have gotten a better, when would the error be less? Further out, you do more terms, you get less error. You get a better approximation. Write the 4th degree Taylor polynomial for g of x equals f of x squared plus 2 about x equals 0. Use p to explain why g must have a relative minimum at 0. Yes. If you want the 5 bonus points. You don't have to have it. was -3 plus 5 times x minus 2 plus, so I'm just, you wouldn't have to write this down again, I just can't still see it, so I'm going to write it down. You know what yeah, everyone know what I'm doing. Yes, no, maybe, possibly. Okay. I'm sure I said this up here, but on this part, remember, I highly recommend on the real AP exam, I think we talked about that. I'm going to blame it on pregnancy that I'm even not sure. Come on, computer. This part right here, we would not probably write anything past that. Y'all know that, right? I said that already. Cool. Awesome. All right, so this is f of x. I want f of x squared plus 2. What do you do if you want f of x squared plus 2? Everywhere you see an x, you put x squared plus 2. Well, what is x squared plus 2 minus 2? So it's kind of it's a composition of functions. We're just putting in the x squared plus 2 in where x is. Any questions about how I got that? No, because there wasn't an x with it, so everywhere I saw an x, I put an x squared plus 2. Yeah, absolutely. Did everyone hear his question? Absolutely. Okay. What degree of a polynomial did it say to write? Said to write a 4th degree. I argue I've made a mistake. Why? I wrote a 6th degree polynomial, didn't I? So I'm going to go back and correct my error. Go, oops. Now at first I thought I needed that one, right? Turns out I didn't. And that's okay. Use P to explain why G must have a relative minimum at 0. What would you do to find relative minimum or maximum or something like that? Do a first derivative. Start with first derivative. And I get 10x plus 12x cubed over 2 factorial. You can do whatever you want. When would this equal 0? My computer is really lagging today. So that equals 0 at x equals 0. So at x equals 0, we agree we have a critical point. How can I tell if it's a maximum or a minimum? I could do a first derivative test, although I would argue it might be difficult to plug in into a first derivative test. Although, good. So it does work, doesn't it? That you can plug in a negative number. Since these are all odds, you get a negative number. If you plug in a negative, you get a positive number if you plug in a positive. So do have a sign change. What other option could you do? Second derivative test. What would you do if you did a second derivative test? So second derivative at x would be 10 plus things with x's. everything else would have an x with it, wouldn't it?
Yeah.
So if I plug in 0 for x, g of 0 is 10, which is greater than 0. Concave up, so I have a relative minimum. It's good to remind you of the second derivative test. To me, the justification on a second derivative test here is a little easier, but both work great. Therefore, relative min x equals 0.
Or actually, a lot of these are actually.
Yeah, sure. As long as you don't say it. It is bad. It is bad.
Well, I thought you said it is a cat.
Maybe it is. I don't know. It's it. What is it? Don't say it, and I will forgive you for using the F. Okay, example number 5. That was 4, I think. 3 we skipped. We'll go back to 3 at some point. It may be on Friday. Before we start this one, let me give you some dates. There are lots of dates. Okay, I'm going to give you 2 worksheets today, and they are series and error worksheets. They're both due on Friday. So today's Wednesday. Tomorrow we are not learning anything new. Friday we'll finish these AP problems. Power series, I'm going to say due Tuesday. You may be done with those already. I don't know where you're at on them, but that gives you plenty of time to ask questions and get those ready Tuesday. Yes. True. Get them ready by Tuesday. So Wednesday we'll grade.
Although I asked this morning, and she Miss Lindsay said it wasn't the first. I was just saying, I announced that we won't be here for everybody else.
Yeah.
Well, I haven't yet the time frame that y'all won't be here.
Yeah. So I just go ahead. But anyway,
We're still.
I think so, but I don't.
Well,
Anyway.
I won't reply to you.
But we're not moving any due dates back, other than we'll just grade on Wednesday instead of Tuesday. Not a big deal. But all the other due dates, we're going to keep them the same. They're just working on AP packet. Yeah, that bottom Friday is a different Friday.
Yeah. Everyone's right here. Get on.
Yeah, go for it.
Wait, are you on?
I will be here. Well, sort of.
So can we come in if we have that day off? Or
5th hour. Yes, not in the morning because I won't be in here.
yeah.
5th hour. You can work in either order tonight. Tomorrow night, or on the So you should have got 3 pieces of paper. You should have got three packets. Great Chair Bound, the Series and Error, and the AP package. We'll do the other 2 AP problems on Friday. Just so you get to see me work 2 more AP problems. But you have all of the material now. You just need to work and ask questions. Tomorrow is the master's exam. Remember, if you get it right tomorrow, you get 5 bonus. Anything that you ever listened to this important for you to know? To me, this is the easiest one to get the 5 bonus points on because it is the most memorization. Normally, they have things you can't, like the derivative one, you had to work as lots of error. This one is truly almost all memorization, right? But just, let's go on that, right? The 10 column wheel. We still kind of this, you actually have to do it.